Hi everyone. Today we start section 3.1, defining the derivative. In this section, we will learn what a derivative is and why it is important. A derivative measures the instantaneous rate of change of a function. In simple words, it tells us how fast something is changing at one specific point. You can also think of the derivative as the slope of the tangent line to a curve. Before we talk about tangent lines, we need to review something called a secant line. A secant line is just a line that goes through 2 points on a curve. Suppose we have 2 points on a function f of x. The first point is a comma f of a. The second point is x comma f of x. To find the slope of the secant line between these 2 points, we take the difference in y over the difference in x, which is f of x minus f of a, all over x minus a. This expression is called the difference quotient. It represents the average rate of change of the function between x and a. In other words, it tells us how much the function changes on average between those two x values. Sometimes it's easier to write this expression in another way. Instead of writing x, we'll let x equals a plus h. Now, the difference quotients become f of a plus h minus f of a all over h. Here, h represents a small change in x. You can think of h as the horizontal distance between two x values. If you look at this graph, this is a, this is x, which is a plus h. H is the distance between a and a plus h. In this graph, my first point is a comma f of a. The second point is a plus h comma f of a plus h. The line connect these 2 points is the secant line. And the slope of this line is f of a plus h minus f of a all over h. Now imagine making h smaller and smaller. That means the second point is moving closer and closer to the first point. As this happens, the secant line begins to look more and more like a tangent line. And that idea is what leads us to the derivative, which gives us the slope of the curve at exactly 1 point.